A very warm welcome to all our esteemed speakers and participants at the Asia Clean Energy Forum 2022 workshop on diesel generator replacement with lithium-ion batteries, organized by India Smart Grid Forum in partnership with Global Smart Energy Federation. Diesel generating sets are commonly used for power backup for all critical infrastructure. Owing to increasing pollution levels, most cities are banning the use of DG sets. DG sets can be replaced with lithium-ion battery energy storage system in large buildings and campuses. It will ensure fastest and cheapest routes to build flexibility for the Indian grid and will also help to reduce the emissions from DG sets, and it will also promote cleaner energy for customers. Innovative business models can be introduced for replacement of DG sets with BESS, which would be the fastest route to create distributed energy storage systems for the grid to build flexibility, which is emerging as the key requirement for renewable energy integration with the grid. With this background, we'll start with today's workshop.
I can't hear. I guess either I'm cut off or you're all cut off.
We can hear, sir.
Here's a quick look at the agenda. Welcome remarks and context settings will be by Ms. Reena Suri from India Smart Grid Forum. The theme presentation on diesel generator replacement with lithium-ion batteries in large buildings and campuses by Ms. Rashi Gupta from Vision Mechatronics. For a panel discussion on innovative business models for replacement of DG sets with BESS, we have Shri A.K. Verma from National Green Tribunal, Mr. Nick Singh from ESCOM, Ms. Rashi Gupta from Vision Mechatronics, Mr. Ravi Sitapati from Biocirrus Incorporation, and Mr. Debashish Banerjee from CESC Limited. This panel discussion will be moderated by Mr. Reggie Kumar Pillai, President, India Smart Grid Forum and Chairman, Global Smart Energy Federation. And the concluding remarks and vote of thanks will also be by Mr. Reggie Kumar Pillai. Now I would like Ms. Reena Suri, Executive Director, India Smart Grid Forum, to give the welcome remarks and do the context setting for the theme, diesel generator replacement with lithium-ion batteries. Reena Suri brings over 20 years of experience in the energy sector. She's responsible for research projects, advisory projects, business development, member relations, and finances of ISGF. Over to you, Reena.
Thank you so much, Ashima. I think we can stop sharing so we see each other. So very good morning, good afternoon, and good evening to all our esteemed speakers and participants. And I would like to extend a very warm welcome to you all to the workshop on diesel generator replacement with lithium-ion batteries that we are organizing today as part of Asia Clean Energy Forum 2022. So diesel generators, are commonly, we all are commonly used for a power backup in developing countries and for all our critical infrastructure, large commercial building requirements and the industrial complexes, such as in the hotels, the hospitals, data centers, for our backup needs. And as you know, in developing world, we have unreliable supply of power. So the DG sets, one, of course, they consume a lot of fuel. They burn diesel, they emit carbon dioxide and other very harmful gases. They also release harmful particles into the atmosphere, which are not good for the air quality and going forward, not good for our future generations. And studies have shown that every liter of fuel that is burned in a diesel genset, it creates a huge amount of pure carbon and carbon dioxide. So ISGF, came out with its latest white paper, which is titled DG set replacement with lithium-ion batteries and commercial buildings, and examined the business models for replacement of diesel generator with the lithium-ion batteries, energy storage systems in large buildings and campuses. So with the study, we have examined and found that the battery energy storage systems could store the generation from renewable energy and from the grid when the power is surplus on the grid, and avoid renewable energy curtailments also at times, and also supply stored electricity to the grid during peak hours. So the cost of electricity from the battery energy storage can be almost half of the cost of electricity from the diesel generator. The battery energy storage systems connected to the grid, they can also provide frequency voltage support to the grid 24/7, and they can be a great resource for the renewable energy and electric vehicles integrated to the grid. And the innovation, we also studied innovative business models that can be introduced for replacement of DG sets with the battery energy storage systems, which would be the fastest route to create the distributed energy storage systems for the grid, to build flexibility, which is emerging as the key requirement for renewable energy integration with the grid. So with this background, I take the pleasure of welcoming all the speakers once again to this workshop. We will start the workshop with a theme presentation on DG set replacement with lithium-ion batteries in large campuses and buildings by Dr. Rashi Gupta from Vision Mechatronics, and our battery wali, as everyone lovingly calls her, who has implemented India's first megawatt scale hybrid energy storage project, followed by a panel discussion on innovative business models. And I warmly welcome Dr. A.K. Verma, Mr. Nick Singh, Dr. Rashi Gupta, Mr. Ravi Sitapati, and Mr. Debashish Banerjee for this panel. Thank you so much for joining us, and a warm welcome to our moderator, Mr. Reggie Kumar Pillai. So with this panel discussion, we are looking forward to hear from our experts, about the techno-economic feasibility of replacing the DG sets with the batteries in the critical infrastructure and large campuses. We also would be looking forward to hearing from them on the additional benefits of electric grid to the electric grid from the battery storage systems for RE and EV integrations, and the different strategies and business models for replacement of DG sets going forward from the battery energy storage system. So without further ado, looking forward to an insightful session today with our esteemed speakers and panelists. Thank you so much, and over to you, Parul.
Thank you, Reena, for the welcome remarks. Now I would request Ms. Rashi Gupta to give the theme presentation on diesel generator replacement with lithium-ion batteries in large buildings and campuses. Dr. Rashi Gupta, fondly known as Battery Wali of India, is a pioneer of manufacturing of advanced lithium batteries in India, along with the world's smartest lithium battery. She is the founder and managing director of Vision Mechatronics Private Limited. Over to you, ma'am.
Thank you so much. Can I now share my screen? Is my screen visible?
Yes, ma'am.
Perfect. So thank you for this opportunity. And today I here present to you India's first megawatt scale hybrid energy storage project. The whole project was all about where the client required a commercially viable solution for sustaining the entire loads for 18 to 20 hours. So what we did was, why do we call it as hybrid? Is because we combined two types of battery technologies into one system. We synchronized them, and we used around lithium and the traditional tubular gel batteries. And we made this a 1 megawatt hour of energy storage system to cater to this need of the client to have varied loads as a backup for 18 to 20 hours. Now, the system is coupled with a 200 kilowatt peak of solar panels, which actually generates the energy.
Sir, please. Sir, please request you to please mute.
Yeah. So,
sorry, go ahead.
So the system is coupled with a 200 kilowatt peak of solar panels, which is the energy generation device and generates. And the whole combination is here to replace a diesel genset here. Now, synchronizing two different battery technologies is the first of its kind in the country. So the whole project functionality, now it is a hybrid microgrid wherein you have, like I said, 614.4 kilowatt hour of lithium batteries, 480 kilowatt of tubular gel batteries, coupled with 144 type of 144 cell type of 200 kilowatt peak monocrystalline solar panels. Now what happens is the load is never constant in the entire project. So the load keeps varying, and when the load keeps varying, you need to size the system so efficiently that at any given point of time, the customer does not have a blackout and the entire diesel genset is completely replaced. So what we've done is, now when we've used a hybrid technology, two different types of battery systems are together. Now we achieve the maximum utilization of the resources, and we achieve the cost of energy at grid parity. It provides a balance between the cost and the backup required. See, because if you see commercially, lithium-ion batteries beyond 4 hours are not economically viable. So the challenge here is also to make things commercially feasible. Now this project has also given a lot of energy independence to the user. Now, the key functions here were that first of all, the lithium battery, so it is a non-flammable, non-explosive, and it uses a very proprietary kind of an active balancing BMS, which increases the life of the battery by 30%. Now, the excess amount is fed back to the grid. Excess solar energy is fed back to the grid. Then there is a complete diesel genset replacement. We have not been using the diesel genset for over a year now. This also has a black start facility wherein you can support the grid at any point of time. I mean, if there is no grid, you can actually have an instant cold start coming in. This really helps. There's a real-time monitoring, and not just real-time monitoring of the system. We even have real-time monitoring of the batteries at the cell level. There is a completely smooth power transition from any source, so which assures a zero blackout, and the response time of the entire system is within 7 milliseconds. So you will not place a blackout ever into the campus. Now, this is a very compact solution. We have flawlessly fitted into a very small room that was allocated to us by the user, saying that this is the only space we can spare for this microgrid. Because real estate is really expensive. I mean, anywhere across the globe, real estate is expensive, and we need to understand how we can have this, the maximum utilization of the real estate with the smallest possible footprint. This also has a very special feature of preventive and predictive monitoring. And in this preventive and predictive monitoring, we actually give a 15 days advance notice to the client in terms of a battery issue or a cell failure or a cell issue, and an instantaneous alert in case of any other fault arising into the system. So this gives him a heads-on time to actually, prepare for any kind of situations that would arise, and they can help them immediately. We can help them. Now, what was the outcome in this? How do you measure this impact? Now, the first most important thing was that the idea of being completely off-grid was fulfilled, because there were times where the client has seen 3 to 4 days of a power cut continuously. So at least now the system is in such a fashion that we can completely, run the system even if the grid is absent. So the capital cost initially was reduced by 35 to 40%, which is a very big impact if you look at by using this hybrid energy storage system. If you actually look at the full capital cost as compared to the full lithium-ion systems. Now, electricity bills today that they are paying are only the fixed charges, and no other charges are there which they are paying right now, only the fixed cost. Now, they have a storage of 7,000 liters of diesel, and at every instance of power cut, they've saved that money. Now, the second important factor of this entire system is that it's a 48-volt DC system, so that it's completely safe. Even for maintenance, you can, even in the live system, you can have the maintenance done, and it's completely safe for the fauna around you, and it's completely operationally safe, even for the human beings and for the fauna around us, because being at peace with the environment is equally important when we are talking of renewable energies. When you're talking of clean and green energy, you cannot impact the environment to an extent where it is damaged. So keeping that impact also in mind is very important. Now, sustainability and scalability, when we look at that, yes, this project is expandable up to 90 megawatt hour, and currently we are in a phase of expanding the system further. Then further we'll go up to 3 megawatt hour now in this case. The next phase is already begun. Now there's a least possible, we have not been using the DG, which has really impacted in terms of the commercial savings that the client has had, also in terms of the environment saving. Now durability, in terms of durability, yes, the entire hybrid energy storage system is of a very long life, 10 to 15 years, which will really give them a much big peace of mind, and they don't have to really bother about replacing many times. The solar capacity also can be expanded as and when required. Of course, when we are going into the second phase of expansion up to 3 megawatts, we will be expanding the solar capacity as well. And it's completely flexible here because the entire system can be expanded as the need is there. I mean, a part of solar could be expanded, or maybe a part of load catering to the system can be expanded, or maybe just this energy storage can be expanded. So it's very flexible in terms of expansion. This is the testimonial from the center head of the campus where we have installed it, where she says that this is a very unique project which will add a lot of value in terms of as the sun is an unlimited source of light and energy. Even this would become a very good source of energy, with which we will live peacefully in harmony with nature in a sustainable way. Now, what are the advantages here? What we have used is in our battery management system is an active balancing battery management system. Now, with active balancing, you can actually, have an increase in the life by 30%. And you can actually have 14% more energy as compared to an identically rated battery capacity. You can monitor the battery health at any given point of time, instantaneously, even at the cell level, anywhere throughout from their application. Now, this is just a glimpse of our remote monitoring. This is the system level monitoring that you have, where it shows what is your consumption, what was the solar generation, what is the battery used. And now this is the cell level monitoring, where each and every cell, in terms of voltage, in terms of temperature, in terms of current that is drawn, everything can be extracted from the system. And we come to know at any given point of time where and when what is happening into the battery cell, and with this data analytics in place, we can give a 15 days advance notice of the failure. Now, this campus, now when we are talking of diesel replacement, which is the most important topic as of today, now the system was designed to replace a DG set of 500 kVA. Basically, the campus has two DG sets of 320 kVA and 180 kVA. Now, the average fuel consumption of 320 kVA is around 55 to 60 liters, and goes up to 95 liters per hour. Now, when you just see, so in case of a 500 liters, when you go, so this is a still higher consumption, and every this would be like about 120 liters when you're looking at a 500 kVA DG. Now, what happens is, now at every power cut, imagine a power cut of 7 to 8 hours, and you are using a DG, what quantum of money is required? And now with now recently there has been a fuel prices revision, but we are looking at at any given point of time, we are looking at an average of 100 rupees per liter. So that is a substantial amount of money. And when you combine a battery pack with a solar energy system, we have actually achieved a grid parity in this case. So the return of investment is much faster. It is much faster as compared to running a DG, and there is no maintenance into the system. See, the maintaining of the DG is also a very repeated a quarterly event which the companies have to do. But here in this case, you do not have to do any maintenance of the system. And when you don't have to do a maintenance of the system, because we are doing a preventive and predictive monitoring of the entire system, it really helps the customer for ensuring a longer life of the system, as well as getting a zero blackout, peaceful power at all given point of time in a very clean, sustainable, in a clean, sustainable way. So this is one example. I mean, this system has been running for 1 year already successfully, and now we are going into the second phase of expansion of the system, going up to 3 megawatt hour. And what we do is now when we say the entire campus, by that we mean including your air conditioners that are there, the kitchen load, the commercial kitchen that they have, which has all the heavy machinery, the water pumps and everything, just like a full-blown resort that you have will be working on this entire thing. So, and of course, now we are also going to add on the electric vehicle charging, though their campus does run on electric vehicles, but the electric vehicle charging stations are also now going to be incorporated into the new next phase, which we are going to add on with a 3 megawatt hour. So now then this campus would be completely green. In every aspect, it would be green in terms of generation of energy, in terms of even the kitchen would be, the kitchen today is running on solar energy. So that also adds on to the value analysis of what we are doing. So when we're talking of a diesel replacement out here, we have reached a grid parity status. And maybe in the next phase, we would be a little less than the grid parity, grid costs. So that would really help, and that would make a better business case for everyone to achieve and to adopt the BESS as in comparing with the DG gensets and looking for a complete replacement. Because this is a live running example. Anybody who wants to visit the site can get in touch with ISGF or us, and we can help you around with that. So with this, when I talk of cost effectiveness now when I've been talking of grid parity and cost effectiveness, now here I'm talking of 35 to 40% reduction in the capital investment, which is a substantial saving. Then electricity bills, you are saving every time because your costs of electricity bill is only the fixed charges that you've been paying. And the value of energy independence is not something that you can imbibe into, the financial models actually. That is an intangible value, which actually says that, okay, when there is a power cut or when there is a failure, when there's no access to diesel, just in lockdowns, there was issue. Sometimes the transportation was not possible. It was very difficult. It was very tiring and taxing. There's no maintenance that they could do at that time for the diesel generator. But today they are completely in a hassle-free situation. So that gives them a very good peace of mind, and then ROI would be well within 3 years for them. So what is the vision that we're looking forward to is like have a global presence, look at what decarbonization of transportation as well as energy storage. And with this, I would just end my presentation. Thank you so much for this opportunity. So I look forward for the discussion later on. I'll just stop sharing my screen.
Thank you so much.
Thank you.
Yeah, thank you, ma'am. Thank you for the presentation. We'll be starting with a panel discussion on innovative business models for replacement of DG sets with BESS. Here's a quick look at our esteemed panelists. The session will be moderated by Mr. Raji Kumar Pillai. Mr. Raji Kumar Pillai is the president of India Smart Grid Forum since its inception in 2011 and is also the chairman of Global Smart Energy Federation since November 2016. He is an internationally renowned expert with nearly 4 decades of experience in the electricity sector. Welcome, sir. We have Ms. Rashi Gupta, founder and managing director of Vision Mechatronics. Welcome once again, ma'am. We have Mr. A.K. Verma. Dr. A.K. Verma is an expert member of the National Green Tribunal in India. He was formerly a member of the Indian Forest Service. Dr. Verma has vast and extensive experience in governance and public management spanning almost 4 decades. Well, a very warm welcome, sir. We have Mr. Nick Singh. Mr. Singh currently holds a position of Head of Smart Grid Center of Expertise in ESCOM. He's in center management, technical support and strategy for research, testing and development and line divisions. Nick has 21 years of experience in the field of electronics engineering and project management. Welcome, Mr. Nick. We have Mr. Ravi Sitapati. Mr. Ravi Sitapati sits on the boards of Power Transmission and Distribution Division of Larsen & Toubro, India, Smart Grid Canada, India Smart Grid Forum and Biceres Incorporation. His past corporate directorships include Toronto Atmospheric Fund, Rice University, and Engineers Without Borders. Welcome, sir. We have Shri Debashish Banerjee. In his current capacity as MD of CESC, he has ushered in a transformation journey to elevate CESC to newer heights of excellence with enhanced operational resilience for effective business continuity during and after any crisis by transfiguring CESC into a more agile, customer-centric and cost-effective digital utility. Welcome, sir. I would now request Mr. Reggie Kumar Pillai to take this discussion forward.
Very welcome, very warm welcome to all the participants from around the world. And it gives me immense pleasure to moderate this panel of eminent experts. Unfortunately, for the third year in a row, Asia Clean Energy Forum is happening online. It has its plus and minuses, and in the past at least 10 editions, I have had the pleasure of attending it personally in Manila, where almost 2,000 plus people converge from around the world, and it has become a signature event in Asia. The advantages of the digital version is that we can have several parallel side events like this. Earlier in a side event, which they used to give us maximum 30, 40, 50 people would sit in a room. That's where we used to do a very limited 5 or 6 side events used to happen in a day. But now that number has increased. In 2020, the first year when ACEF went digital, we were given a side event on blockchain applications for utilities, and we had more than 1,100 people from around the world, and a 90-minute session went on for almost 3 hours, and there was so much of question answer interest from the audience, and we had speakers from all continents. In fact, that was very interesting scenario compared to the physical events which we used to do at Manila. Then last year so the blockchain which we introduced in 2020 became a mainstream event in main ACEF last year, and ACEF has given us 4 side events last year. So 2 of them which we introduced for the first time. One is electric cooking, another one is district cooling systems. Both of them this year has moved to the main ACEF themes. There are presentations, discussions going on in one of these days on both electric cooking as well as in district cooling systems. And this year we have 2. One of them is today we are doing on DG set replacement with the lithium-ion battery or battery energy storage systems. And tomorrow, same time, we'll be doing on grid integrated vehicles. So on the theme, enough has been talked about, and Dr. Rashi Gupta has made a very interesting presentation on the first megawatt hour scale microgrid with the lithium-ion battery, which has been done just outside of Delhi in Maneshwar area, and it was commissioned sometime last year in the summer, just before the summer. And this is the only facility which I have seen where the switchover from the grid to the battery system and back is flicker free. So good a BM must they have implemented. It's really an engineering marvel. I request people to visit. And this has the scalability, as she said, can go into much higher than 1 megawatt hour, and they are already expanding it to include more applications in the campus. So without taking much of your time, I will invite each of the panelists to have an opening remark, 3 to 5 minutes, and thereafter we'll get into different question and answer. And there are a lot of questions for you, Rashi, in the chat box. I would request you to go through that and find some answers for some of that in the meantime. So let me start with Dr. A.K. Verma. Sir, very warm welcome to you. And Sir was our Joint Secretary in the Ministry of Power, and we had the pleasure of working with him for about 5-6 years when he was in MOP. And Sir, although you've been on a private holiday and being in London, you kindly consented to join. And today you are sitting in a position where you can actually implement policy, or you can come out with policy interventions so that some of this can be made mandatory through National Green Tribunal. So over to you, Dr. Verma. He's not. Yeah. Yes, sir. You are there. You can unmute it and speak. Please unmute, sir. You are muted. You have to unmute. You can do it yourself.
Now it's okay?
Yeah, it's fine. Perfect.
Okay, so once again, I mean, I convey my happiness to be with you all. The 2-3 points that I wanted to bring to the panel. One is that India is a land of possibility and potential. So our growth has to go. And because we are very popular, so we certainly create a lot of stress on our environment also. And therefore the environment and energy both are to be looked after very say sensitively and innovatively, and a balance has to be created all the time. Our energy needs are going to be I think 3 to 4 fold in coming 5-6 years. As on today, our per capita energy consumption is much lower compared to the world average, almost 1/3. And if you compare with the developing economies also of our size, we do stand at least 20% and 30% of them, not more than that. So energy consumption is going to be, as a simple calculation is that by 2030 we may need a 800 gigawatt of say generating capacity in our country. And today what we are say consuming about 1200 odd billions of units of electricity will go almost 3000 billion units. So your energy requirement is going to increase. And also if you go by the information available in the public domain, then almost more than 50% of your installed capacity is going to be from the non-fossil fuel by 2030. So in that circumstances, the grid stability, the distributed grid, distributed generator concepts, and more use of renewable is going to be. So there must be some storage capacities. That's one aspect. The other aspect is the air pollution. Air pollution in our country has been of very high level, you can say. The climate change. I see that the climate risk, India stands at almost third, or they say third, but even if it is not third, fourth or fifth high risk country, then also what India needs is energy security, the climate resilience, and the sustainable consumptions. So we have to look after those things. Say on the advice of the say or direction of the NGT or Honorable Supreme Court, a lot of things have happened. And in case of the water pollution, in case of the air pollution, in case of the say critically polluted industrial clusters, I mean in India 253 river stretches are highly polluted. 102 cities are such which has not attained the ambient air quality level. And similarly, more than 100 clusters are which are severely or critically polluted. So even for the development of the industry, unless we develop a proper sink or less polluting generating or producing capacity, we will not be in a position to grow well. And see, whoever is the entrepreneur, if he is going to use the energy and if he is going to pollute or increase the environmental stress, the system is such now the society has become more conscious, the courts are active, and the legal regimes are very restrictive at times, you can say, from the business point of view, if you go, because ultimately what you are doing is you are inflicting the cost on others. There is always a cost of conservation, and you are not bearing the cost, somebody else, society is bearing the cost. And therefore the lot of legal regimes have come up. There are provision under CRPC, there are provision in the Water Act, there are provision in the Air Act, and the criminal prosecution can be done. And apart from that, because this prosecution takes long time, so on the polluters pay principle, says a lot of fine, the pecuniary punishment you call, or the compensation you call, is there. And particularly in case of the DG sets, a lot of things have been done depending upon the size of the DG sets. If it is say smaller size, below 1000 kWA, then 10 to 25%. If it goes above 1000, then it is 1 lakh rupees or things like that. Even the say lot many sustainability criteria have been developed for the air quality also. How much we carbon dioxide, how much would be nitrous oxide, how much would be the particulate matters, how much would be the other kind of pollutants. And those criteria have been developed based on that: poor, good, moderately polluted, all those categories have been defined. And any industry which are particularly the DG sets, when you are using, then you are supposed to do many other things, like you have to you have to try to devise, rather the contrive the system in such a way that you control the noise pollutions, not only at the level of the machine. You have to reduce 25% of the noise pollution, at least 25% at the muffler level. Then you have to do at the enclosure level. So that also entails a lot of costing. And as Ms. Rasi has been, Dr. Rasi has been presenting, now the diesel cost have gone up. These things are very, very important, and the NGT and the Honorable Supreme Court has already given direction when it should be DG sets should be replaced by the gas-based sets. Also, during certain period in the NCR region, you cannot operate the DG set. There is a committee which allows and which does not allow, and all these things have happened. There is a graded response action plan in the NCR region, and for the whole of the country. Now, those states which have got the non-attending cities, they are supposed to develop a city action plan, as well as the state air pollution control plan, and they are being monitored at the highest level in the governance, highest level at the bureaucracy level, as well as it is being monitored by the courts also. So the risk is there. The point I'm saying, that the risk is there, and the risk is to the business, risk is to the environment, risk is to the humanity, and therefore we must try to find out the alternatives. Battery has been one of the great alternatives, but the cost was very high. Technology was also changing, and when the renewable is going to be in such a large extent in our system, in our energy mix, then you must have some storage capacity also. Battery is the only storage capacity, because if you go for the hydro sectors and storage capacity you want to build up, I mean, it's not so easy. It's not the potential sites are less for the PSP, and even if the potential sites are there, the cost is high. And the third is still it is dependent upon the electricity, where you and power sector in our country, the thermal power is contributing almost 50% to the emission of our country. And therefore, if you want to use the renewable in a larger way, you have to have the say storage capacity in terms of battery. Your EV, the entire EV campaign is dependent upon the battery. Now the technology is important. Technology now, as Dr. Rasi has been telling, the lithium-ion batteries are now becoming more and more financially or economically viable and technologically possible to be compact. Just yesterday or today's Times of India carries a article in the opinion section, where the Niti Aayog has come out with the battery swapping policy, the draft policy. So all your EV will be dependent upon the battery swapping, and then lithium-ion battery will have a much bigger say utility in the EV. So entire and the sound pollution is reduced to bare minimum. There is no sound pollution almost in case of the battery. There is always certain environmental load when you go for any kind of development. Now it's a matter of having a trade-off. And if battery would be one technology, I understand, where that trade-off will be in favor of the environment, where the energy use will be increased, but the environmental stress will be reduced also. So so opening understanding is that if the technology has been, say, matured and financially it is viable in the regime of the increasing say crude prices, the lithium-ion battery could be a much better substitute to replace the DG sets.
Thank you, Dr. Verma. And in fact, we must compliment National Green Tribunal for being very forward-looking. 4 years ago, they came out with the order. They realized that the DG set, running of DG set in this national capital region, which is the most polluted city in the world, is not sustainable. And at that point in time, in 2018, when the NGT order came, the battery prices were in the range of $300 to $400 per kilowatt hour. So they recommended gas, replacing this with gas, or running it from October to March with gas. But today, the prices of lithium-ion batteries have come several times lower. It's somewhere in the range of $120 to $150 per kilowatt hour at the cell level. And also the gases rare to find in India. There's a shortage of gas. So time has cut. Yes.
I think one thing that, Reggie, is very, very important about the portability.
Yes.
Make gas available everywhere is not an easy task. You can make it available in a bigger city, but making it available in all the rural area. Now our climate resilience activity is widespread throughout the country. So in the rural area, availability of gas becomes difficult at times. And portability, the amount of gas that you have to carry for that, and the amount of the ion battery, lithium-ion battery that you have to carry is, so the portability is also very important aspect of technology.
Exactly. So now it is time that NGT may revisit this order, and
I think I'll be crossing my brief if I make such statements.
We call upon NGT to revisit that.
Just
order.
off the cuff, I'd let you know, but such decisions are taken on the advice of the technological teams, the CPCB, the state pollution control boards, and they bring to the table the state of the art, say technology being applicable or being found in the country, economically viable and things like that. So in due course of time, I mean, it's a matter of bringing the technology to the knowledge of the adjudicating courts.
Thank you, sir. So now I will move to Mr. Nick Singh from South Africa, who's been a pioneer in microgrid development in that part of the world. And over to you, Nick.
Thank you, Chair. Thank you, esteemed speakers. Thank you for this opportunity. I'm from the power utility Eskom in South Africa. We're the one of the largest power utilities in the continent. I think it all starts with environmental responsibility. I think that's the word, the buzzword today. And with that, Eskom has now committed a just energy transition in the country, a JET strategy, to ensure that we now move to an aspiration of net zero emissions by 2050. Now that's quite a big, landmark to try to achieve. Right now, as a country, we, as Eskom, produce 45% of the emissions in the country. So you can imagine why it's so important as a utility to try to move in this direction. Clean energy, is something that everybody aspires to. I think as individuals, as companies, as countries. And this discussion today is quite an interesting one because there's been significant advancements in battery or storage technology over the past 5 years, I would say, that has really changed the way we look at storage. Reggie, you're 100% correct. I think we are approaching the $120, dollar per kilowatt hour in terms of batteries. And unfortunately, I am a fan of storage, but lithium is a finite resource. We need to accept that, it's not a resource that's in abundance. We're going to run out of it eventually. It's good for now, but we need to think about the long-term, how we recycle this. From what I understand, you can actually do quite a lot of recycling from lithium battery technology. And the aspiration is try to find some sort of storage technology that's green, that's not going to give us the longevity, but also the responsibility. So it's a no-brainer that, for now, as it is with battery technology, most definitely a diesel replacement. There's no argument about that, right? But however, as we move forward, there's going to be quite a few other storage technologies that will play quite prominent parts in this new regime. With renewables and, green hydrogen is happening everywhere. We all know that we can start producing that. Hydrogen, forms a very good storage mechanism as well. But then you need the fuel cells to be able to, use this energy, which is also quite expensive right now. So I think, there's a lot of benefits and a lot of disadvantages. But as it stands now, I'm quite firm that you replace diesel gens using battery technology. It's a no-brainer. But we need to think about the longer term objective. So I'm quite interested how I can contribute in this conversation. Thank you, guys. Reggie, you're on mute.
Yeah, thank you very much, Nick. And let me now move to Mr. Ravi Sidapati from the other part of the globe, but currently in India.
Thank you, Reggie, and good evening to all the panelists. I see many in the audience that we have shared the podium before. So it's a very good meeting place of ideas. I'd like to build actually on what's been said, and I think there are three opportunities I see. I'm quoting something from your own report, Reggie, and that is, if 70,000 megawatts is the DG capacity in India, currently it does not offer, other than an energy support, it offers no power system support. The battery system, if implemented, that itself allows you to become an online power system support, provided the regulatory side goes through with it. So that is number one. So not instantly, but after the conversion, you have now a very vocal real-time support as opposed to a non-real-time energy support in the form of diesel generation. Number two, I'm going back to Canada almost 12, 13 years ago. Even though we are having about 80% of green energy overall in the country, we were the first one to have a carbon tax imposed on us from 1990. That 1990 $20 per ton carbon tax, which was arbitrarily imposed when the world was sitting at $1 and $2 a ton of CO2, today is rising at the rate of $15 to $20 a year and will be capped at $175 in the year 2030. We are today, as we speak, we are sitting at $70 a ton. So I think there has to be a kind of a pointer also, while we keep talking of pollution and all that, somewhere the needle has got to move to say, this is serious business. Like interest rate movements of the RBI, there has got to be, certain movements in the area of greenness as well in the environmental system. So that is one. Second, when we moved into this area years ago, and in fact, we have, of course, in Ontario banned all coal-fired plants, we took the healthcare cost and we found, in fact, I have numbers here, which of course, it's a discussion, so I won't share it. But the healthcare cost alone paid for the premium of green energy that we brought on since 2008. Because we have a public healthcare system. Now, India is moving into a public healthcare system. If not now, it'll probably be so in 5 to 10 years. At that time, what are you going to do? Because this is going to be hanging on the exchequer's balance, isn't it? So you have a second force that's actually compelling you to go this particular way. The third one is the financial return. And to some extent, I have to compliment Ms. Malik here for having hybridized it with lowering the cost from an all-out lithium battery to a lithium tubular battery. It is well positioned maybe to add a zinc flow battery, which is what Nick was alluding to, which I agree with him. And then from the flow battery, because we have got zinc flow batteries in Canada that we have implemented. and then finally on to maybe a hydrogen, maybe 5-10 years later. So that continuum continues. And so the fact that she has been able to think of a hybrid battery, decoupling energy to power, I think is a very, very important step. And maybe that aspect alone should be highlighted going forward, because it is what brings the cost down. Otherwise, the cost becomes always one of them. And the last one, and I'll stop here, is while ancillary systems do not provide any incentive global, forget just India, globally ancillary services are not priced to provide any premium service. And I'm not going to harp on that, but with V2G, you may have a better support with utilizing these batteries, because as electrification of transport occurs, as you saw in the Calcutta project that we did, Reggie, there is need for actually local battery system support from time to time without having to take on the stress on the electrical grid. So I'm looking at all these as business opportunities. Some will be clamped down by way of penalties and punitive measures. But I think the battery system offers far more opportunity now than the diesel generators ever did for almost the same set of capacities. So I'll stop here and then I'll articulate later. Thank you.
Thank you. Thank you very much for mentioning about the Calcutta study. And so with that, let me go to Mr. Debashish Banerjee, Managing Director of CAC Calcutta. Sir, over to you.
Yeah, a very good evening. We have been seeing that over, I remember maybe decades ago when you used to visit Delhi, we had eye burns, where the eyes used to burn because of a lot of carbon monoxide being pumped in the air. And but going forward now, we don't feel the burn because people have been, sensitized on the matter of air quality index. And that time, I think it was not there. So I would liken it to the kind of movement where, transport is moving from the conventional fossil fuel based to electric vehicles. And yes, in the city of Calcutta, there is already 75 electric buses which are running, and it's going forward to 1,000 and 2,000 more. So, and obviously we are providing the electrical infrastructure for charging these high-speed, buses. We are also building up, the ecosystem for the electric vehicle mobility. Obviously, there are metro railways, there are electric ferries, there are electric trams, and so on and so forth. So when you draw a similarity between this, DG sets are the ones which are operating on the kind of fuels which have a lot of SOx and NOx emitted into the air. We understand that wherever the private utilities are serving this country, whether it's Mumbai, Calcutta, or Delhi, they are providing 24/7. So generally speaking, DG set should not be required. But then DG sets are kept as a big standby, and they're kept by the buildings, whether it is the healthcare industry, whether it is the hotels, whether it's so on and so forth. And we understand when we talk on power creating a lot of, fossil fuel power creating a lot of, environmental issues, let me tell you, 28% of the energy related CO2 emissions come from buildings per se. So it's a point of use. So at the point of use, electricity at the point of use is the cleanest, safest, and most affordable system as we are talking about electric mobility, and we talk on electric cooking as well. So we understand the diesel generating set capacity in India is 95 gigawatt. I don't know, right figure, wrong figure, I got a figure, and it's increasing. So now what's the alternative? What is the healthy alternative, the cleaner alternative? Obviously a battery storage system. Now, why a battery storage system? Because, battery storage system, unlike a DG system, is just not sitting idle. DG sets are sitting idle in the system. And there's a capex incurred, but it's not being used. Because in cities like this place, we don't use it. Now, whereas when you use a battery energy storage system, we had tried out battery energy storage system in Calcutta on a small distribution scale of 315 kilowatt hour. And we have found that it is these kinds of storage systems, they are multi-talented, when it's not like DG set not in use, not working. and there's kind of asset. And we have found out 1 year of study that, you know, we are able to derive a small energy arbitrage by charging it during the lean hours, low cost of peak hours, and discharging during the peak hours. It has also helped us share the load when there are peak loads in the city by taking a part of that load. And obviously, in terms of deferral of capex, yes, but the cost is very prohibitive currently. The footprint is very prohibitive currently. But as trillions of dollars, billions of dollars are going in for making battery storage in India, we hope that the economy scale going forward would be better. So even in terms of deviation settlement mechanisms, frequency management, and renewable power intermittency, we found it to be good. So we tried that. We also tried, we have just done a floating microgrid with a floating solar and storage. Now going forward, we feel that battery energy storage can have a good potential. And as a utility, we feel that if we convert all the DG sets to a battery energy storage by the user, by the C&I user, that is commercial industrial user per se, they themselves, we can use them on maybe a lease model or whatever it is, and we don't need to do further capex. Now, every utility faces a problem of import of power, right? The import or transmission network is clogged. So, you don't know how to do it. Yeah, I was in Mumbai before for 11 years. That side is clogged. When we talk on this eastern side, we feel that going forward, it will be clogged with the huge peaks rising. So at that point of time, this embedded generation in the city as battery energy storage would actually help serve the city per se when there are peak loads. And then we don't have to do those capex because you understand in Calcutta, our peak load is about 2000 megawatts, whereas the average loading would be 1600. So there's a misuse of that. So if you can shape the peak and use that embedded generation, like we have generation embedded in the conventional fuel, but also in the clean side, we can do it. I think it can serve as a model and we can use energy as a service for that along with the consumer. So that's my limited take on it. Thank you very much. Reggie, you are muted.
Sorry. So let me come to you with a question. In the summer of 2019, we had 2 MBA students doing an internship here. We given this topic, the cost-benefit analysis of DG set versus lithium-ion battery as a internship topic. So they went around and did a lot of research and came out with a draft paper. When I look at it on a return on investment, Dr. Rashi Gupta said that today ROI looks at 3 years for that project which she has done. That time in 2019, the diesel prices were still somewhere around 60 rupees a liter in India. And that was not coming anywhere near 3 to 5 years ROI. So we talked to the utilities here in Delhi that if I replace a megawatt scale DG set and put a megawatt hour scale battery connected to your 11 kV system in a big hotel, what is a economic benefit you can give it to us? So I am going to invest that money and putting in the BESS there, and definitely the DG set owner is going to pay me some money, but that alone is not enough for me to have a proper return on investment. So I need some money from you because 24/7 my battery is giving you support. So these are the 1, 2, 3, 4 benefits. So they said they will work on it, and no number could come because there is no regulatory clarity. There is no norms. As we speak, there is no norms. How can a utility compensate a third party who is putting in a battery? So today, you being the managing director of Calcutta in CESC, so if I come in and put in a 1 megawatt hour battery in one of the hotels there and replace that DG set, just think about what kind of a compensation CSC can pay me in addition to what I can get it from the hotel owner. So this, let's park that. I don't want a number today, but this is the kind of thing which we should do. So we didn't get anything in that year, or more than a year we waited from the discoms in Delhi. And then finally, the diesel price gone above 90 rupees in 2021. And then we published the paper saying that this is good enough. So now with a 5-year ROI battery, if the electricity is bought from the grid at 9 rupees, store it and give it back, it can still be half the price of what it is from DG set. So that's how finally last year we
What,
published.
baby?
Yeah.
Yeah. So let me come with that. Let me come to.
No, it's fine.
Can you mute that?
Talking is a good thing.
Can you mute somebody talking? Yeah. So let me come back to Rashi. There were a lot of questions for you. Some of them important ones you already answered. Maybe you could read out for the benefit of the audience. Over to you, Rashi.
Rasi, before you speak, let me make a small anecdotes. What Reggie was talking about the business, and Reggie, let me share one fact with you. Reggie, you are muted. Reggie.
Yes, sir.
I want to share a fact with you.
Yes, sir.
In one of the state in a city where the dowry goes as a normal practice during the marriage,
Yes.
DG state used to be asked as a part of the dowry system at some point. Then came the standalone solar system. So a standalone solar system was supposed to be the that city of the state is supposed to be the largest market of India for the standalone solar system.
I know exhibition road in
yes. And then DG sets were not in demand because the operational cost was much higher. Here
Yes.
it is free of cost, the operation and things like that. Similar thing is there. I mean, just apart from the joke, the fact remains that if the business model develops automatically, where battery becomes financially more viable, technologically available, and physically easily available everywhere, I mean, DG city has no life then. But the second point is very, very important, which Nick has made, that maybe that we do not have the inexhaustible stock of lithium. So recycling of lithium is also one thing that one has to think about. That's just by way of my observation. I made some, nothing more.
We'll come back to you on that topic, on the recycling part, but let Rashi answer some of the questions of the audience.
Yes.
Yes, sir. There have been a lot of questions. I've answered quite so many. And see, basically, there are questions like, what happens on the footprint? As I've said, when you put in a diesel generator, the footprint required is much higher as in compared to a rooftop solar and a battery energy storage system. Like here, the DG room that the client has is twice the space given to us to put the BESS of 1 megawatt hour, where he houses a 500 kVA DG as compared to a 1 megawatt hour. So the footprint given to us is half. So now you can understand half the capacity of the DG compared to one capacity of batteries, and half the room required for the batteries compared to half the capacity of the DG. So it's inversely proportional basically. Now, yes, you have to comply to the grid code of the country to have the BESS feeding back to the grid, and we have done that also in our project. Then, yes, you can use this into the rural areas. So where the project that is installed in outskirts of Gurgaon is a rural area, which has this electricity connection, which is very intermittent, and we have very frequent short power cuts and a long duration power cuts as well. So this definitely makes sense. Now, are the DISCOMs allowed to be the owner of storage systems in India? Yes, anybody can be an owner of a storage system in India. And I think BSES Rajdhani in BSES Yamuna are very good examples of in putting up storages, and they are the owners of these projects. So that is one thing. Then
10 megawatt hour storage system is installed at
by AES, yeah. Tata Power.
TPDDL Delhi. That was the first actually.
That is also a good project to be mentioned. Yes. Now, how does there's one question on LCOE of DG sets increasing as compared to LCOE of BESS? See, what happens is, BESS is typically a very capex heavy kind of a project, while DG set is an OPEX heavy kind of a project. So when you actually have the LCOE comparison, why do I say that ROI comes in 3 years? Because your maintenance costs, your fuel costs are ever increasing. While at the same time, the capital investment that you've made on a battery energy storage system is just a one-time thing. It is not going to recurringly keep increasing. And that's when, you know, the LCOE actually matters in terms of a capex heavy project versus an opex heavy project. So actually the ROI can be well within 5 years, as Reggie sir has also mentioned in the ISGF paper. But for our project, we have worked out and it comes to well within 3 years. So the LCOE really matters. Expected life as compared to DG, what are the environmental conditions required for for the batteries and inverters? Yes. Now, when we come to environmental conditions, let me tell you that there are two types of impact assessments that one has to do. One is the impact of the BESS on the environment, and the second is impact of the environment on the BESS. Now, both of them are very important, and these have to be assessed well in advance before putting up these projects. Because now in our case, we have maintained the temperature of the BESS at between 25 and 30 degrees Celsius for the effective life and performance of the BESS. However, there is a zero pollution concept in this, because we are not emitting any kind of gases or any kind of fumes or smell from the system. So that impact is not there. Also, being a very low voltage system, as a 48-volt system, there is a zero impact on the fauna, which is also one of the environmental impacts to be assessed into the systems. Then, so now life of the DG is as good as you maintain it, and the fuel that is available and how clean your fuel is in terms of putting it into the DG. Now here, the clean energy is from the solar panels. It's renewable energy which we are storing. So yes, overall life is much better. Environmental impact is much lesser, as well as when you compare it to the DG, it's a cleaner source. So most of the questions are now answered, and I think we can go to more of the questions from the panel and move forward.
Thank you. Thank you. Let me come to Nick. You wanted to say something.
Just to add one thing which Rasi was telling, the environmental criteria for use of the DG set. In any commercial and the residential area, just the noise, noise level should not increase more than 65 decibel at any point of time. I mean, most of the DG sets just violate it because of
Agree, sir, agree. And now when you compare it with BESS, I would like to add that it's absolutely noiseless, completely silent operation.
That is one aspect. And the air pollution, I mean, ultimately diesel adds to the SOx, NOx and all those things, which battery does not generally do not do. But then battery itself, I mean, the lead battery used to be the lead very, very polluting item, which is not in case of the lithium-ion batteries. That's one of the aspects that I think that Mr. Reggie was going to Nick. I came in between.
Yeah, Nick, over to you, Nick. Thank you, sir.
Thank you. Not a problem, Dr. Verma. So I think I just want to add to the conversation in terms of, I've seen a couple of the questions there. And that's something that we've experienced firsthand. I've got quite a few lithium-ion plants that have been running from as early as 2014. And the lesson learned is that you need to ensure that your depth of discharge of your lithium-ion technology is within the range, right? So that's the trick. You know, you'll see a lot of lithium-ion batteries that will tell you you can achieve a 90% depth of discharge. And at 90% DOD, you're going to probably get 8,000 cycles from it. But if you look at that curve, if you reduce your depth of discharge down to probably between 50 and 60%, the cycles increase exponentially. So the point that I'm trying to get across is that you rather invest in larger amount of storage and reduce your depth of discharge. So you got a little bit higher upfront capital cost today, but you will not need to replace those batteries in 10 years' time. Those batteries should last easy over 20 years, according to the studies that we have done. And I think that's a very important lesson that needs to come across when dealing with this technology, is your depth of discharge and where to actually take it to, and how do you get the maximum bang for your buck, basically, from that infrastructure. Okay, thank you.
Nick, the point you were making about the reduction in the depth of discharge, and you were saying that it will increase the longevity of the battery. Will it also give the stability to the power supply itself? Is there any study?
So when you talk about stability to the power supply, I'm assuming that you're talking about flexibility services on the grid. Is that what you're referring to?
Yeah, that's the point.
Yes, 100%. But Dr. Verma, what you need to understand is that lithium on its own will not suffice. You need to have a blend of storage technologies. As Ravi said earlier on, flow batteries are fantastic for baseload type of agreements. You know, you get 100% DOD, you move your chemicals from one to the other and you produce that energy. But unfortunately, it's 1C discharge capability, right? Then you get lithium ion, which I've seen are now improving to up to 5C, 5 times the charge, the discharge capability, which is fantastic, right? However, we all know if you stress a battery to over its C rating, you significantly start decreasing the life of that battery. Now, the third option of storage is supercapacitors, which is something I didn't talk about. But solid-state supercapacitors are getting there. So solid-state batteries are also getting there. So the trick is to have a mix of technologies so that if you have extremely high peaks, you deal with those peaks using the supercapacitor for that short period of time, right?
Okay.
Then you use your lithium ion as your gap filler in between and your base load as your flow technology. So it's a combination of technologies and managing all of this together. Okay.
Thank you.
Can I just add in?
Please.
Yeah. Now, two important aspects is I completely agree with Nick and Raviji saying that there should be hybridization or a combination of multiple technologies. This is what is, I mean, just two of them which we added here is a first step move towards moving that. Now, something that I want to add on to what Nick said was that by reducing the DOD, you can have an increase in the life cycles. But there is one small rider, which is the shelf life of the batteries. So to everybody listening to this, please get a verification from the manufacturer that what is the shelf life that they're looking at. Because even if you have 20,000 cycles, say by reducing the DOD, for example, the battery may not last for 20 years. So there is a rider on that. So that is just one clarification that I wanted to make here, because this would just not let everybody under the impression that if I just increase the cycles, it will give me a longevity on my battery. It may not. Some manufacturers do agree to this. Some may not give you that longevity of the battery.
Now, Dr. Rashi, that was confirmed by the manufacturers, and
okay, then it's good.
Yeah, and accelerated live testing of those cells actually proved the same results. So
okay, and then that's fine. Then it's absolutely fine.
Yeah,
some do not. So let them have this from confirmation from the manufacturer before getting it to this adoption.
So invite Mr. Banerjee.
Yeah. Thank you. One question is, when we talk for utilities, we must all know that the consumer does not want a tariff rise. So whatever we may discuss on the forum, if you are looking on to pass on the investment cost to the consumer, the tariff, people who are in this sector would know better that you are not going to get that. And so whatever you need to do, you have to ensure that the TCO, that the total cost of ownership for a period of whatever you calculate as payback, maybe 5 years, 10 years, it will be tariff neutral. The second point is when we talk on DG sets for cities like Calcutta, Mumbai, Delhi, etc., who can afford a storage, right? The storage, we may say, can be done by rural. Rural of Gurgaon and Noida is not rural. Rural of India is so different than the rural we talk on Gurgaon and Noida. That's what I feel so. When we talk on the capacity to expend money is on the urban cities. And when we talk on urban cities, we talk on utilities who have substations. So your competition or footprint space is not vis-a-vis a DG set, but vis-a-vis a substation. Whether it is 11 or 4.4, or if you go for a large scale where there's 33 by 11, that is the issue, because we will have to embed a storage system in a grid, which is in an urban city where land is very scarce. So we will have to think like we have made substations or 33 by 11 substation on G+2 or G+3 going vertical. So those all philosophies have to be brought up, as well as the cost economics, whatever you call it, ROI, ROC, and nothing beyond, break even. When I don't know, Giriji is talking 5 years, 10 years, I don't know. We don't talk on any break even beyond 1.5 years to 2 years to put in any kind of money, So, and then obviously, as I said, the regulator will only look at being tariff neutral. That's all. So that was my limited take. Thank you.
Thank you. So we mentioned about the flexibility. So according to the latest IEA report last year, Indian grid needs 85% flexibility by 2040. So as Dr. Verma said, by 2030, our power system will double to 800 plus gigawatt. And by 2040, it will be somewhere like 1600 gigawatt. So out of which more than 900 gigawatt is going to be just solar and wind, on which nobody has any control other than God. So when it comes, when it goes, we won't know. In a power system with that kind of 60% of the total capacity coming from solar and wind, we need 85% flexibility, which only power companies are going to invest into flexibility, all different technologies. It's going to be a huge investment, which ultimately will get transferred to the man on the street who is paying the rate. So ratepayers may not be able to afford that. That's why we need to look at other systems of bringing in flexibility through different routes. So this is one of them. So as I said in the beginning, 70 gigawatt of DG set, even 10% of that we are able to replace it. It's going to be distributed across the country and it's going to be huge. And Mr. Banerjee talked about 95 gigawatt. So there are different numbers, but the key is that it's much more than 50 or 70 gigawatt of large capacity DG set, not the smaller one which you have at home, which is 5 kilowatt, 10 kilowatt. These are all we are talking about megawatt scale or closer to megawatt scale DG sets. So this is one. We also talked about district cooling systems, which comes with thermal storage. So tens of thousands of tons of turnover of chilled water that again can give flexibility to the grid. And many other routes, electric vehicle integration. With tomorrow we have as I said, V2G or grid integrated vehicles session tomorrow at the same time. So all these different options for integrating these resources with the grid, so that flexibility is built into the grid. So with that, I'll come to you, Ravi sir, on your perspectives on flexibility. We had a couple of webinars last year in different forums on flexibility and the need for flexibility.
I think there are three trends here. Whether we like it or not, we are going to hit and we have to face it. One is this flexibility issue of coal-fired plants being able to be maneuvered or being shut down in various metropolitan cities. The second is the onslaught of solar. And today in California, we have a duck curve that nobody knows even how to utilize during the middle of the day. And it is incapacitated simply because they have not implemented a time of use. When Ontario went, we were the first jurisdiction in the world with smart meter to also implement time of use, so that we can take advantages of what the grid does on various times of the day. So I think that is another sort of structural impediment you have. But let me throw the last one, which I think the customer is going to basically not care about what any government guy says. If the price of fuel keeps where it is, if natural gas prices today is, if gasoline is sitting at 50, 60% higher, natural gas is sitting at 250% higher today. And that's the reality in our part of the world or in any other part of the world. So if the price of these fossil fuels remain high, the customer is going to say, I may not want to own anything to do with fossil fuel implementation, whether it's a vehicle, whether it is power supply or whatever. At that time, I think what you will see is the premium for actually being able to run their businesses, their fleets using energy storage system in the C&I premises, whether it is tariff neutral or not, will automatically come because the customer is going to get fed up, basically. Now, the commoner is who is the one that's going to get affected with tariffs. So the question is, how do you feed the haves and the have-nots? And that is a policy question that you have. But I can tell you businesses, just like they put their own captive power stations 15, 20 years ago, they'll just go and put all these systems the moment they can find it is convenient to them. So somewhere the government, I think, needs to be careful as to how it evolves its policies and not just keep on postponing every policy to some debate in the future. And I think that is my sort of, I see this trend already coming, and I don't think you can bypass it.
Well, you mentioned about the duck curve in California. So 2 weeks ago, we had a good session with Clyde Luton of California ISO, who is the inventor of that so-called duck curve. So yeah, it continues to be a problem in geographies where they are slow to TOU. And in India, we are currently doing a pilot project. Just 2 weeks ago or 2 months ago, we started a pilot project in UP with the approval of the regulator, a real-time pricing project. We are recruiting about 100 customers who will be given pricing signals half an hour to 1 hour ahead, and they will be motivated to reduce their load, or in times of surplus, they will be motivated to use more power. So that project will run for about 9 months, and that will going to be a very interesting project to see how we are going to implement real-time pricing or TOU tariff implementation. So anyway, coming back to the flexibility issue, it's going to be a major challenge. Nobody knows how to address this 85%. They're talking about IEA takes 50% ramp up and 35% ramp down. So that's how plus minus 85% they arrived at. So we need to have more and more discussions and deliberations on this part in the coming days, and to have a roadmap, actually, integration of this 500 gigawatt, which is proposed by 2030, and maybe double of that by 2040. So the business of running the grid is going to be much more challenging, exciting than what it used to be in the last 100 years. So we are almost near end of the time. So we'll come back to each one of you for your parting comments. So starting with Dr. Verma, over to you, sir.
Yeah, my sense is that in coming days, we will have to depend more on the energy system, which are less polluting. Otherwise, the cost of conservation, the cost of pollution mitigation process is going to add to the entire business. And whether we like it or not, the violations are being reported these days. There are a lot of active consideration to minimize it. And then the penalties are so high, which act as a deterrent to the business itself. And therefore, my sense is that coming days belong to a less polluting technology for the energy conservation, energy production, energy utilization. So energy security through the less polluting system we have to do. And in that, batteries have a role. Even the thermal fired, says the coal fired plants are the super critical and all. And the Japanese model coming these days are bringing some kind of flexibility. So if the flexibility is possible, even by the mix of technology, they should develop the mix of batteries, mix of chemicals, mix of say alternative sources, whatever be the methods, but it has to come. And renewable has to be used in the maximum possible to the maximum possible extent, and technology will have to emerge to meet it, because there is no other way out. I mean, a country like ours, which need more and more energy at affordable cost, as President Mr. Banerjee is there, he can tell us. I mean, increasing the tariff is not possible, and simply restricting the tariff to increase and giving says a better quality of electricity round the clock at affordable price is not possible. So therefore, technology has to change. So some methodology has to come where we use more and more of the renewable energy. Thank you.
Thank you, sir. Over to Mr. Banerjee, then we move to the other experts.
Oh, it's okay. I think what we have all discussed about is, making it more sustainable, more better for the future generations in terms of the planet and the people. Yes, I would obviously stress on the fact that electricity at the point of use is very clean. So when we talk on this thermal storage, which you are talking upon, it is a very good alternative in shifting the peak, because we need to shift the peak to off-peak periods, because now you understand the entire India is facing this issue, and specifically for the fuel and the coal. Yes, it's going to be a mix of hybrid of the base load as well as the peak load managed by the conventional and the graduation to the conventional fuels. But yes, maybe like today we are talking on DG sets being replaced by storage batteries. Tomorrow the heat pumps which are used in buildings, which actually generate a lot of GHG emissions, can be replaced by electricity. Or the electric or driven the furnaces which are driven by oil and gas can be put to electric furnace. There are many applications which can come up, but as I said before, and I would say again, all these technologies, the tariff, the expense has to be borne up by the consumer. So hence there has to be the return, the whatever you call it, ROI, whether you call it ROC, we call it TCO, we call it NPV, we call it ARR, any name you put it. But the consumer, we will have to find out that the benefit will be derived, and the discoms are already bleeding and everybody knows that. So they'll not be able to add more to the cost. But yes, if it replaces some inefficient in value systems in the grid or the network, it will be taken forward. And today, I feel the CNI consumers, that is the commercial industrial consumers who are using these sets in the cities, we can convert them to storage. And as Reggie was saying, we can start with some of the big customers. They will be, because they have the climate change mitigation agenda. They also have to meet it. It's not that only power plants need to meet it. The commercial industrial consumers have to meet it, and the climate change agenda in West Bengal also is driven very strongly. So I think we will have to make this an entire ecosystem to go forward. And this bottoms-up approach that is spreading out as an embedded generation for the storage and conversion this of big CNI customers would actually help them and help the ecosystem move forward. That's all.
Very good. Thank you. Over to you, Dr. Rashi Gupta.
Well, I completely agree with what Debashishi has just said. See, what happens is, the climate mitigation is everybody's responsibility. Include each and everybody, including every citizen of this globe, not just India. We all are equally responsible for it. And we all have to contribute in a small or a big manner in whatever capacity we can to get this climate change mitigation done. And what we need is completely sustainable and a circular ecosystem. We need recycling, we need reuse, and something which is missed out in this discussion, and I'd like to quickly touch upon, is the second life of the batteries also, which is coming out from the EVs or maybe big, large storage systems, which can be used for a second life. Yes, we need to implement that. We need to implement recycling. To a certain extent, these things are falling in place, but we need to have much larger capacities installed now in terms of having a recycling infrastructure, because by the time we are ready with this infrastructure, we will have a large capacity of lithium-ion batteries coming out for recycling. So this needs an immediate attention right now. Now, when we talk of cleaning the energy in the energy ecosystem, we have to do a lot of work in terms of all the energies, not just electricity. Electricity is just one form of energy. We need to clean each and every form of energy that we have to actually have a sustainable ecosystem for the next generations to come and for us to breathe. And us to live and survive to have the next systems, next generations. So we need a complete cleaning of energy. So we all have to collectively to work towards, whether it is an individual, whether it's a corporate, whether it is educational institute, whether it is government, all of us have to work towards it. And the younger generations have a much larger responsibility to share, to educate, and to propagate that yes, cleaning of energy is needed. So that's all from my end.
To Mr. Ravi Sitapati, over to you, sir.
Yeah, I think in simple terms, if I sum up, I see three issues. One is the trend towards technology and investments is not where your problems are. Today, we have seen the world over that investments can flow if you provide the right atmosphere and the returns. So that is not your constraint today. The constraint is the signals that we send to such investment houses. Whether it is punitive because of dirtiness of power, or whether it is assistance in the terms of incentives to be provided to be able to shift technology, in my view, is one area that probably India needs to address. The second is the fact that India imports its fossil fuel itself must be converted into what is the national premium it's willing to pay to be able to get off this big tiger. It cannot continue to keep on increasing. Today, even coal is being imported. And so it's not a very good scenario to be in. So the question is, policy-wise, what is the premium is the government of India willing to pay to be able to get alternative technology such that it can get off this tiger and start actually decreasing it? Third, I always believe, notwithstanding how good we are at heart and how charitable we are at home, price signal always matters. If we are not able to send a cognizant price signal, we have failed in our policies to set the trend for the nation. So those are the three things I will leave my thoughts with.
Thank you, sir. I believe Nick Singh had to leave, but he is connected on a phone and he will speak.
Chair.
Please connect, Nick.
No, thank you. I am actually driving to the airport, so I'm listening to the conversations. I agree with all the speakers thus far. And, I think we talk about climate change, but with climate change comes, individual change. And I think that's reinforcing everything that was said here today. That, it's how we need to change as individuals, both socially, our patterns, the way that we look at life, the way we prepare for the future. And we need to be very cautious that whatever decisions we make, be it technology decisions, that it needs to be sustainable ones and for future generations as well. I think Dr. Rashi spoke about second life batteries. By all means, those are good initiatives. But what I found out with second life technology is that, you're actually passing the buck over in terms of your responsibility. Instead of you disposing of technology, you're passing it off to the next consumer and making it their problem. So I think we need to be a little bit more responsible when we look at these bigger solutions. I believe that renewables is most definitely the future and will stay. I'm a firm believer that green hydrogen as a storage mechanism will be the future in the next 5 to 10 years, right? It's sustainable. There's some gaps in terms of technology, in terms of fuel cells, etc. But I believe that, when there's a need and there's a challenge, we will overcome that with technology. Okay, thank you for a fantastic session. Thank you. Bye-bye.
Thank you, Nick. Have a safe flight. And that brings us to the end of this interesting session. We overran by only 10 minutes, so I take a couple of minutes to conclude. The main point is that DG sets needs to be replaced. There is no second thought about it. And this are several benefits, including that this fossil fuels are imported, which we can save a huge foreign exchange, and the emissions from DG sets. So why lithium-ion battery, which we proposed? So we looked at a couple of years ago, about 4 years ago, we embarked on a program of making an energy storage roadmap for India. That was the first such exercise we started along with India Energy Storage Alliance and NIDI Aayog. We worked very closely with NIDI Aayog, MOP, CEA, MNRE, etc. So when we set out, we examined all the energy storage technologies, and we found that nothing will be able to compete with the lithium-ion batteries in terms of prices, and also the flexibility with which you will be able to deploy that. A megawatt scale storage system can be deployed in months, whereas in any other technology it takes several years, and this can be shifted from one location to another location for different applications. So those kind of modularity, and it can be, you can start with 1 megawatt hour, can go to 100 megawatt hour. It's so flexible, modular, and anytime, at least till end of this decade, lithium technologies will continue to be the most cost competitive. Well, many people talked about lithium is not infinite. There are many new technologies and many new players coming into the field where lithium is being recycled or retrieved from recycling of the batteries. And first, the second life of the batteries, which are removed from the electric vehicles. For the mobility applications, you need much higher efficient batteries, more reliability. The ones which are at 90 or 95% efficiency EV batteries, which you are removed, which can again use for stationary applications, for grid support, and many other applications for 5 to 10 years. So typically a battery, you are talking about recycling after 15 to 20 years. And there are many new technologies coming up. So 2 months ago, I visited, they are considered to be one of the best technology companies which could retrieve lithium from used batteries, big batteries, not small. It's called TESS in Singapore. So I had visited their factory 2 months ago, and a week later they were acquired by a Korean conglomerate, SK Group. So TESS has some small operations in India also. They were talking about scaling it up, and their factories are going to be online in 2022-23 in many countries, including Europe and Australia and China. So they are the world leaders actually in lithium, and almost all 70 to 90% of the most of the materials they are able to recycle and take it out. So this is and there are some companies in US and in Canada and in Germany who are working on the recycling of used lithium batteries. So I'm sure that with the prices of lithium, which has gone up, when Tesla was launched, lithium was somewhere around $6,000 per ton. Today it stands somewhere close to $80,000 per ton. So this change happened in 10 years. So definitely, as a material becomes more and more expensive, technologies and players will come in for recycling. So second main point which we all agreed on is that there has to be innovative business models and new technologies, so that no burden on the consumers. So we have always been looking at introduction of new technologies without any burden to neither the ratepayers nor the taxpayers. So no subsidy, no grant, but efficiency improvement. And in India, there is a lot to work on that area. Our AT&C losses, if we are able to reduce it by few percentages, few hundred crores of investment will be can immediately taken care within a year or two, that will be paid back. So we have great opportunity from this efficiency improvement without burdening the ratepayer or the taxpayer to implement and introduce new technologies, and that should be the main focus area. So with this concluding words, thank you everybody who joined this program, and the recordings and the presentations will be emailed to all the registered participants. We had more than 400 people who registered for the program. I think close to 200 unique people came in and gone during this last 100 minutes. So thank you very much, all the participants.
Thank you, Rizvi, for this.
A small request to keep the cameras on. We have going to have a quick photograph session for esteemed panelists. Reena, please switch on your camera. Only the speakers.
Some of the participants who are still there can also switch on the camera. So the picture will look good. Otherwise, it will be a lot of blank. Those who are there, please switch on your camera. Let's have a group photo. Yeah, that's very good. So, Parul, could you manage the pictures?
Yes, sir, just 5 more seconds will do.
Anyone else?
We're done, sir.
Yeah.
Thank you.
Thank you. Thank you. God bless.
Thank you. Thanks a lot.
Bye.
Thanks all. Bye-bye.
Thank you so much. Bye-bye.
Bye. Have a great evening.
Thank you.
Great evening, everybody. Bye-bye.